So only 32 minutes. Okay. Today we are going to discuss about the derivation of Rydberg formula. Actually, yesterday only we started this one. Derivation of Rydberg formula. Okay. In derivation of Rydberg formula, the delta E, the total energy, the difference of energy, the delta E equal to En2 minus En1. Okay. There En2, the energy of second orbit, the energy of excited orbit. The energy of excited orbit is actually that energy of an electron. 2 pi square m k square z square E4 by n square h square, that is that too this is excited orbit. Okay, and next minus 2 pi square m k square z square e to the power of 4 by n1 square h square. This is the energy of ground level orbit electron. The energy of this is energy of excited electron, and this is energy of ground level electron. And here minus into minus plus will get, when this n1 if you take this side, n1 h square if you take this side will get that equal to 2 pi square m k square z square e to the power of 4 by n1 square h square minus 2 pi square same m k square z square e to the power of 4 by n2 square, and here h square. This is n2 excited electron. And delta E we know already. What is the delta E? The delta E is nothing but delta E. We can take this delta E that equal to h nu. Yes or no? This h nu equal to h c by lambda. Why it is h c by lambda? Then nu equal to c by lambda. Yes or no? Frequency equal to velocity by wavelength. Nu equal to c by lambda. That's why the delta E we can write as a hc by lambda. Okay. And here the delta E is nothing but hc by lambda, that equal to, in this we have to take common thing common మొత్తం తీసుకోవచ్చు n1 h square తప్ప మిగిలిన మొత్తం కామన్ తీసుకోవచ్చు. ఎట్లా 2 pi square I am taking common from these two, 2 pi square m k square z square e to the power of 4 by the common one is h square. Yes or no? H square. The remaining will be 1 by n1 square minus 1 by n2 square. Is it clear? దీంట్లో n1 square n2 square తప్ప remaining మొత్తం all are same. That's why we are taking common this one. Okay. Yes, here I am one more continuously listen. ఇక్కడ ఏం చేస్తున్నాం అంటే హెచ్సి, ఇక్కడ హెచ్సి ఉంది కదమ్మా, ఈ హెచ్సి ఎక్కడ తీసుకొస్తున్నాం, డౌన్ కి తీసుకొస్తున్నాం. ఇట్ విల్ మల్టిప్లై, ఇది ఇక్కడికి వస్తుంది ఇప్పుడు. దెన్ వాట్ విల్ హ్యాపెన్స్ దేర్, 1 by lambda, 1 by lambda equal to 1 by lambda equal to 2 pi square m k square z square e to the power of 4 by, ఇది హెచ్సి ఇక్కడ వచ్చింది కాబట్టి సి h2 కాస్త ఏమవుతుంది, ch cube, h square will become cube into 1 by n1 square minus 1 by n2 square. Is it clear, everyone? And here where 1 by lambda, where 2 pi square m k square z square e to the power of 4 by ch cube is a constant. This total is constant, amma, that too Rydberg constant is constant. It is equal to Rydberg constant. It is equal to Rydberg. It is equal to Rydberg constant. Okay, if it is equal to Rydberg constant, what we can write, that 1 by lambda, that equal to Rydberg constant is R. And z square, z square and atomic number of that element, particular element, always z square is 1. Mostly it will be 1 only. Z square into 1 by n1 square minus 1 by n2 square. Okay, this is R. This is the Rydberg formula. This is Rydberg formula. This Rydberg formula we can write as a one more type also, or here we know already the 1 by lambda, the reciprocal of lambda equal to wave number, nu bar. Yes or no? So that's why you can take this nu bar, that equal to r z square into 1 by n1 square minus 1 by n2 square. Okay na? ఒకవేళ వేవ్ నంబర్ ఇచ్చిందనుకో, we can use this formula. వేవ్ నంబర్ క్యాలిక్యులేట్ చేయమంటే, లేదు వేవ్ లెంత్ క్యాలిక్యులేట్ చేయమని అనుకో, we can use this one. Did you understand? These two formulas are Rydberg formulas. Okay, these two are Rydberg formula. అమ్మా ఇవన్నీ ఎక్కడి నుంచో రాలేవు, జస్ట్ ఇప్పుడు ఎట్లా అంటే, ఫర్ ఎగ్జాంపుల్ హియర్ the velocity c equal to lambda into frequency. Yes or no? Wavelength into frequency. So their wavelength, their frequency equal to c by lambda. C by lambda means here 1 by lambda, that equal to, we can write this one as a frequency equal to c nu bar also. Why? Because that 1 by lambda equal to wave number. Okay, that's why instead of 1 by lambda, we wrote here wave number. Okay, this is energy of excited electron, and this is energy of ground state electron. And remaining these total are constant. This total constant, this is equal to Rydberg constant. Yesterday I have given Rydberg value also, constant value. Okay, shall I remove this? Okay, I am removing this one. I will give one question based on Rydberg constant. The question is, calculate the wavelength of wavelength of first line of Balmer series first line of Balmer series in hydrogen spectrum. In hydrogen spectrum. This is the question, right? Actually, yesterday we wrote here. This is a Lyman series. Lyman series, it starts from ground level to 7th orbit. And Balmer series, it starts from 2nd level to 7th orbit. First line and first. The first line is nothing but the Balmer series. Second lines to 3rd excited state is the first line, amma. And second shell to 4th excited state is second line. And second shell to 5th excited state is the 3rd line. So these lines we have to consider from right to left. It nundi ikkada teesukovala. Okay na? So that means in Balmer series, how many, amma? Actually, this is N2, and this is N3. And this one is the first line. The electron will goes from N2 to N3. Second shell to 3rd shell. And next to second line is nothing but the electron will goes to second shell to 4th shell. Did you get the clarity? So now what is the question here? Calculate the wavelength of first line, the Balmer series in hydrogen spectrum. First line is nothing but the second shell to 3rd shell, amma. That means in N1, for first line of Balmer series, N1 equal to 2. Yes or no? This is N1 level and this is N2 level. The N1 equal to second shell and N2 equal to 3rd shell. N2 equal to 3rd shell. Did you understand this one? Yesterday we wrote the hydrogen spectrum. If you check the hydrogen spectrum, we know already this one, the Balmer series from at the right to left nunchi vachedi first line, first line, second line, and next if it goes to another 3rd line. And one more important point I forgot to say yesterday, always this first line is called alpha line also, and second line is called beta line, and 3rd line is called gamma line. Okay. In sometimes in question they may ask alpha line of Balmer series, beta line of gamma Balmer series, or gamma line of Balmer series and would adgochu. Alpha line is nothing but the first line, and beta line is second line, gamma line is 3rd line. I hope everyone understood. Now here we are talking about only first line of Balmer series in hydrogen spectrum. First line, in first line Balmer series, the N1 value 2, ground state is 2, second energy level, and excited state is 3, 3rd energy level. That means N1 equal to 2 and N2 equal to 3. Now calculate the wavelength of this one, right? So there we have to use the formula to calculate it. Rydberg formula. What is that Rydberg formula? 1 by lambda equal to S. 1 by lambda equal to R Z square into 1 by N1 square minus 1 by N2 square. This is the formula to calculate wavelength of lines, spectral lines. Okay. Right. 1 by lambda that equal to R into 1 square. Why? Because of this is hydrogen spectrum. The hydrogen atomic number 1. That's why R into 1 square. And 1 by the N1 value is 2. 2 square minus 1 by 3 square. Calculate it. 1 by lambda that equal to R. 1 minus R ఎంత వస్తుంది? ఇది చేస్తే 4. 1 by 4 minus 1 by 9. If you do the LCM, we'll get lambda R. What we will get, Tali? The LCM of these two, 36. 36, 9 minus 4. That equal to R into 5 by 36. If it is 5 by 36, 1 by lambda equal to R into 5 by 36 amma. 1 by lambda. Then lambda equal to the 36 will come upwards. 36 by 5R. Yes or no? 36 by 5R. Lambda equal to, this is the value of 1 by lambda. Then lambda equal to 36 by 5R. And lambda equal to 36 by 5 into 1 by R. We can write like this also. Yes. Why? Because we know already the 1 by R value. Yesterday I have given one, check it. The 1 by R that equal to 9.12 into 10 to the power of minus 6 amma. 10 to the power of minus 6 centimeters. That equal to 912 angstroms also. 912 angstroms. Substitute R value here. The lambda equal to 36 by 5 into 9.12 into 10 to the power of minus 6. Calculate this one. Do the simplification. No need to change this 10 to the power of minus 6. Did you get the answer? Okay, I will give here only. I will give the answer here. The answer will be 65.66 into 10 to the power of minus 6 centimeters. Or we can take this one, 6566 angstroms also. Both are same. Okay, is it clear here? Calculate the wavelength of first line of Balmer series in hydrogen spectrum. First line alpha line, second line beta line, third line gamma line. In Balmer series nothing but N1 value second shell and N2 value is third shell, and that too in Balmer series only. Okay, N1 equal to 2, N2 equal to 3. This is the formula, Rydberg formula, 1 by lambda equal to RZ square into 1 by N1 square minus 1 by N2 square. Okay, now this Rydberg formula we can use to calculate the wavelength of various spectral lines. ఈ ఫార్ములాని యూజ్ చేసుకొని మనము వేవ్ లెంత్ క్యాలిక్యులేట్ చేయొచ్చు స్పెక్ట్రల్ లైన్స్. ఓకే, I am going to remove this one. I will give one more question for you. Okay, next question, Amma. The question number 2. Calculate the frequency of frequency. Calculate the frequency of the last line of Lyman series. Lyman series in hydrogen spectrum. Last line of Lyman series in hydrogen spectrum. Amma, here you have to remember the Lyman series N1 value. The Lyman series N1 value 1 only, but N2 value last line annadamma. Last line ante it will not end with 7. I told you already etc. yesterday. Ante 7 kante ekkuva kuda undochu. Last line is nothing but unlimited. So the N2 value is infinity. The N2 value infinite. Okay, infinity means 0. Now, so here the N1 value 1 and N2 value 0 amma. Ante infinity, that means 0. Now calculate the 1 by lambda value. Calculate 1 by lambda. After getting 1 by lambda value vachindanko, then I will explain how to calculate frequency. Frequency equal to C by lambda amma. So there frequency equal to C 1 by lambda. Yes or no? అంటే ఇక్కడ 1 ఉన్నట్టే, C 1 by lambda. అంటే ఇక్కడ ఏంది, if you get the 1 by lambda value, that value you have to substitute here. The nu equal to C into 1 by lambda will get the answer. C we know already, the velocity 3 into 10 to the power of 8 meter per second. Okay, are you able to do this one, or shall I explain? Calculate the frequency of last line of Lyman series in hydrogen. The first line is N1 value 1 only, but N2 value is unlimited, infinity. ఎందుకంటే పర్టికులర్ గా మనం ఏం చెప్పాం, Lyman series N2 value, the Lyman series of N2 that equal to 2, 3, 4, 5, 6, 7, 8 etc. ఇట్లా పోతూనే ఉంటది. ఒక particular place లో ఆగదు లాస్ట్ లైన్. Okay, now here the answer I am explaining. Formula, what is the Rydberg formula? 1 by lambda equal to rz square 1 by n1 square minus 1 by n2 square. Okay, n2 is infinity, nothing but we can take as a 0. So 1 by lambda that equal to r 1 square and 1 by 1 square minus 0. This total value will get 0 only. So 1 by lambda equal to r. Sorry, ఇక్కడ 0 రాదమ్మా, ఇక్కడ 1 వస్తుంది. 1 స్క్వేర్ అంటే 1 into r వస్తుంది. So here the 1 by lambda value we got here r. Okay na? And that to Rydberg constant. Now we have to calculate the frequency. The frequency nu equal to c by lambda, and that's nu equal to c into 1 by lambda. And 1 by lambda value we know already, that is r. So nu equal to c into r, and that nu equal to c value 3 into 10 to the power of 8. Okay, that is a meter per second summa. If it is centimeters, 10 to the power of 10 into Rydberg constant. What is that in centimeters? 109678 per centimeters. Here centimeter per second. Put చేయండి. Calculate this one. After calculating nu equal to 3.29 into 10 to the power of 15 will get 15 per second frequency. అర్థమైందా? Did you understand? The last question I will give. Shall I remove this? Okay. And next question. This you have to calculate and you have to say the answer. Calculate the wavelength of of third line of bracket series. Third line of bracket series. Third line of bracket series in hydrogen spectrum. Bracket series in hydrogen spectrum. Simple. That answer, the n1 value, what is that? N1 and n2. The bracket series n1 value, what is that, Amma? 4. And n2 and a third line and 4, 5, 6, 7. N2 is a 7. Now calculate this one, which is very easy. Already we done first question according to this one only. Are you able to do this one, or shall I explain? Give a response in chat box. Okay, do it. The boys are not responding. Do it fast and send the answer in chat box.